welcome guys. So welcome to our GRE Physics section. So 91. It's very happy that we will finish off this very soon. So be sure to subscribe to my channel. Okay, so 91. Basically you have Carnot cycle and this is TS diagram. So TS diagram is hard to read, but all you need to catch is the important quantity like TC and the TH. These two quantities are important. Okay, and that's all. When you did and then there's nothing you can get. Now, which of the following gives the ratio of heat above the to the work during the cycle? Okay, so what's the what's QBC, right? QBC is when QBC, right? Basically, QBC is the increase from the. So there are two heats in the Carnot cycle. One is in the cold part, and one is in the hot part. Okay, and you just ask about this QBC. So basically, he's asking about Q of cold divided by W. This is the ratio of what you want to find. Okay, and remember that the one important formula is the Carnot efficiency. Basically, W over QH is 1 minus TC over TH. And QH or minus QC, which is W. So you have some formulas and then you have some parameters, so you just plug in. So this is 1 minus this, just plug TC and TH. So you get the QH over W is this one. Okay, so you can use this to, since you know this, so you know that QH over W minus QC over W is close to 1, so QC over W is 29.5. You just plug in this one, right? So the answer is very close to 30. Is 29.5. So the answer is E, 30. That is very stupid question. You just plug some parameters, then you solve it. So 92. Okay, so 92 basically is the square, the infinite box potential, infinite box. Okay, so there are multiple ways to solve it, but I suggest that you should remember the wave function. By the way, when I solve this problem, this is reminded in my head, so I didn't go to Wikipedia and copy. I always remember this. So n equals to 3, then you can write down wave function, and it's just ask about wave function from x equals to 0 and 6 over L over 6. So phi 3 square is 2 over L sine square 3 pi over x over L, and then you do the integral. Okay, and by the way, this integral is easy to do because you can write this term as half minus cosine L6 pi x, and then and when you do the integration, this will give you sine 6 pi x divided by L. But when you plug L over 6, then you will become 0. So this term must be vanished. So the answer is 0 to L over 6 to over L half. Yeah, done. So it's L over 6. So it's 1 over 6. If you don't have the if you don't have time, then you can guess it's 1 over 6 because you take 0 to L over 6. So you can guess if it's uniform, then you can guess it's 1 over 6. Okay, so 93. Basically, you don't have to see any problem. You don't have to see any relation. You already see. Basically, it's asking about the special derivative and which one is invariant. The answer is E, right? because we know that x prime p x prime must be the Lorentz Lorentz transformation, and t prime also related to the transformation, and you can basically you know that the x and ct are due to, and ct will have the Lorentz relationship. Basically, they are controlled by the Lorentz group. And the common fact that the energy and P times C will have the same relationship as this. So basically, all of these four terms, any individual of them will not be the Lorentz invariant quantity. So the only Lorentz invariant quantity is the 4 vector. So the answer is E. The answer is E. So 94, basic electronics, basically 3 identical. The first capacitor is charged V0 and disconnected from the battery. Another 2 capacitors in the uncharged and connected series. Okay, so here comes the fact that you need to remember something. If I give you 2 capacitance, if they are series, then the total capacitance is 1 over 1 of C1 plus C2. If they're parallel, they are C1 plus C2. Basically, these two relationships are different from reciprocal if you change C to be resistance. Okay, so series. So this one is C, this one is C. So you tell me that C is C over 2, right? Or is C tilde. So basically, you have 2C, and after that, it looks like some C, which is only C over 2. But although this is correct, but what they want to ask is about the final voltage. So you know that because it's disconnected to a battery, so which quantity is fixed? Which quantity is fixed? The quantity fixed, right? The quantity fixed is the charge. So basically, in the beginning, we have a charge Q, which is CV0. Which is CV0, and so this is the first one. So that so the final circuit look like this, and in the beginning it has a CV0 and a Q. So after the final and all of it will share by some voltage. So let's call it V. So CV0 will equals to CV plus C over 2V. Okay, so now you can view these two as parallel. So you can solve V is 2/3 V0. That's it. Done. So 2/3, the answer is D. The answer is D. Okay, so 95, a charge of negative 5 μ distributed uniformly around 1 meter radius. A point of charge 3 is at the center of ring. The work required to move the point charge in the direction normal to the plane to the ring. Okay, so maybe we need to draw a diagram to see what's going on. So you have a ring, and then you also have a charge. At the center of the ring. So you ask about the work required to move the charge 1 meters in a normal direction plane. So basically, you want to leave this charge into this one. It's 1 meters, and ask about the work. Okay, so one important thing you need to remember is that if there is a charge Q, your charge Q, and this is R, then the potential is just KQQ divided by R. You don't have to do the integral because all of these have the radius R, large R. So this is the answer. And then when R equal, so when you hear that this is just KQQ over R. This should be energy. So for the potential, there is no SQ. It's KQ over R. But what we need is energy. So we need KQQ over R. So we need to KQQ over. So this is 1. The beginning is 1. So it should be here. Plus KQQ over. When this is 1, this is 1. Then it's square root of 2. So this is the answer. So we can plug in. Basically, it's when we find the answer, then we can know that it's positive or negative. So if we miss something, then we know that. So case in 9 to 10 times 10 to the 9th, and 5 times minus 3, 3 times minus 6, and times 1 over square root of 2. Okay, and the answer is close to this one. 39.5 times 10 to the negative 3. So the answer is A. The answer is A. Okay, so 96, the magnetic field inside a long coil of wire has certain magnetic direction when the coil area is filled. So basically, if you add a diamagnetic object into the region, then the magnetic field will start to decrease a little bit, but the same sign, right? This is the common sense. So the answer is C. The answer is C. Okay, so 97. 97, actually we don't have to do any computation. We can just see a graph. Basically, ask about the Lagrangian. So Lagrangian is the moment kinetic term minus potential, right? So the A, B, C, D, E, the kinetic term looks the same, but you need to minus and then you also need to minus potential. So there is a potential term here. So the potential term must be positive, right? So the only possibility is A or C. It's A or B, because these two are minus. So the only thing is which one is correct. But remember, you need to minus the potential. So you need to minus mg times some positive number. So the answer is A. The answer is A. Basically, that's it. Right, because you know that it must be kinetic term minus some potential terms. So you know that A is the only possible choice. Then you don't have to do any calculation said that maybe you need to write a cosine theta 1 into like 1 minus theta 1 squared divided by 2. You don't have to do this. So that's it.